Hi Precalc, this is a video on writing equations given graphs. So like we've been doing with transformations, only this time kind of going in the reverse order and taking a graph and coming up with an equation that goes with it. So learning target is I can write an equation given a graph. This will be a pretty quick video. I think if you know what you're doing with transformations, this shouldn't be overly difficult. So example 1, you are given this orange graph over here. One thing I would do is add some arrows to it, and you'll have to draw these in your notes the best that you can, but it's definitely a parabola. I think that's pretty obvious. So the parent equation for that one is f of x equals x squared. Okay. What I would also recommend doing is just starting to sketch the parent equation on your graph. I think that helps give an idea of what it used to look like. That way we can a little bit easier figure out what the new one is doing. So I'm going to do that in red. So that's an idea of what the original parabola would have looked like. Okay. At that point, we can describe some transformations. So first of all, the shape of it looks exactly the same. So I don't think there's any horizontal or vertical stretch. There also doesn't appear to be any reflection. Although I guess it could be a reflection across the y-axis, but I'm going to assume that it's not. I'm going to assume that all that happened is our graph went 1, 2, 3 to the left and 1, 2 up. So left 3 units and up 2 units. No stretch, no reflection. Nothing else. So our new equation then, that left 3 is going to be a plus 3 on the inside. That's the opposite of what we think. And then this one is going to be a plus 2 on the outside. So when I write my new equation, I need to create an inside. So x plus 3 on the inside, that gets squared because it's quadratic. And then a plus 2 on the outside. And what you can do here too to check your work is you can just hop on Desmos or any sort of graphing software and just type that in and make sure it looks like what we think it should look like. So we think that it should be x plus 3 plus 2. And that looks like what our graph looks like. You can test a couple points. There's the vertex at -3, 2. There's another point there at -2, 3. So looks good. All right, next one, parent equation. It's a V shape, so that tells me that it's an absolute value equation. So absolute value of x. And then what is happening to it? Well, I think there are 3 things happening to it. So again, I'm going to kind of start with what the parent function would have looked like. Maybe add some arrows up here as well. So the vertex definitely moved. It went left 1, 2, 3, 4, and it went down 2. So left 4, down 2. I don't think there's any reflection, but there is a stretch on this one. So on our parent graph, I'm just going to look at the slope of the right side. The slope of the right side was 1. We went up 1 over 1. So your slope was 1. Now the slope of your right side is up 2 over 1. So your slope is 2. That means you've been stretched vertically by a factor of 2. So vertical stretch by 2. Okay. So our new equation, we have to put our vertical stretch in. So a 2 out front. And then left 4 is a plus 4 on the inside. And then down 2 is a minus 2 on the outside. right, another absolute value function. So again, I'm just going to start with what the parent looked like. Used to look like that. So this one has definitely been reflected. It's upside down. So it's reflection over the x-axis. It's upside down now. It's also been slid to the right 3. So here's where our vertex was. Here's where it is now. It went to the right 3. And then this one definitely looks skinnier than, or fatter, I should say, than it used to. So it has some sort of stretch going on. I'm going to use a vertical stretch once again. So remember, our original slope was 1 of our right side. Now the slope of our right side is down 1, 2, and over 1, 2, 3. So it's a negative 2/3. Now I already talked about a reflection, so that takes care of the negative. So I'm just going to say the slope of the right side is 2/3, or the vertical stretch is 2/3, positive 2/3. Since we already took care of the reflection part, the negative part. Okay, so our equation is negative 2/3 times the absolute value. We need to go right 3, so x minus 3. And then there is no, there's no up or down there. Okay, so once again, I think it might pay to check on Desmos. So try that, negative 2/3 times x minus 3. I have that one up there already. And there it is. We can zoom in on it. You can test a couple points. So 3, 0, and 0, negative 2. 3, 0, and 0, negative 2, which is what we had on there. So that's good. All right, just one more here. This one, I think it helps if you add the arrow there. So this is the square root parent function. Square root of x. So I'm going to draw what that used to look like. It used to be 0, 0, 1, 1. Square root of 4 is 2. So that's our original parent function. So first thing I would do is just look at kind of where this ending point started. Or the starting point, I guess. Where did it start? And then where is it in our new one? And it looks like we went up 2 and right 3. So we went up 2, right 3. And then what else happened? Well, it used to be like kind of pointing to the right, and now it looks like we got flipped over and we're now pointing to the left. So what happened is at some point it got reflected this way. It got reflected across the y-axis. So if it got reflected across the y-axis, that is on the inside when we go to write our new equation. If it gets reflected across the x-axis, that's happened before. That happens on the outside. So this is a negative on the inside, and then an up 2 and a right 3. So our new equation, nothing on the outside. We don't have any vertical stretch or any reflection across the x-axis. We have our square root sign. We have a right 3, so that's a minus 3 on the inside. We have an up 2, and then remember we need this reflection across the y-axis on the inside. So we need to put a negative right here, and actually we need to put that guy in parentheses as well, so that it does what we want it to do. So that minus 3 still shifts it to the right and not to the left. And then I tested this one on Desmos too, just to be sure. So let me show you, if we would have not put those parentheses in there, then it actually ends up shifting it to the left, which isn't what we want. So we want to put those in parentheses, or you could actually leave it without parentheses, but then you need to turn that to a +3 instead of a -3. So either one of those options would work for this one.